earlier we have 13.1, which is equations of tangents and normals. Okay, so tangents and normals are things that are not unfamiliar to us. Okay, so we have touched on tangents before already, and I believe we have touched on normals before as well. Okay, but maybe just to do a very quick recap. Okay, in a very generic situation, if let's say I have a curve, something like that, okay, and I have a tangent being drawn at a certain point, so let's say maybe this point, okay, then my tangent will be passing through that point only of that curve. So let me adjust this a little. Okay, so this line itself is what we call a tangent. And then for a normal, okay, a normal will be perpendicular to the tangent. So looking something like that, passing through that same point. Okay. So essentially our tangent and normals, they are actually straight lines. So they will obey our straight line equation of y equals fx plus c. Okay, and because our tangent and normal, they are actually perpendicular to each other, so their gradients will actually multiply to each other such that it's equals to -1. Okay, so let's say y is equals to fx over here. Our gradient of tangent can be found by differentiating our fx, okay, our y, and then our gradient of normal will be -1 over the derivative. Okay. Okay, so this is a critical concept that will help us to answer most of the questions for this topic. So let's look at try 1 first. find the exact gradient value for this particular line, okay, we will find that at the point itself, where x is equals to 2, our dy over dx, okay, will be computed in this manner. So 4 times 3, 12, and 18. Okay, so gradient of the tangent will be 18. Okay. So now we proceed with trying to find out the equation of the curve of the tangent. Okay, so y equals fx plus c, y equals 18x plus c in this case. Using that point 2, 15, y is 15, x is 2, and we find c. And c will be negative 21. Therefore, equation of the tangent will be y equals to 18x minus 21. Okay. Any questions? At part 2, we want to find the equation of the normal. Alright, the normal is at B itself. Okay, so we can use the derivative dy over dx to find out the gradient of the tangent at B. But to find out the gradient of the normal itself, we must remember to take negative 1 divided by the gradient of the tangent. Okay, so at B, dy over dx will be this. So that's 9. And the gradient of the normal will be negative 1 over 9. So equation of the normal will be negative 1 over 9x plus c. And then to use the point, and we find the equation of the normal. Any questions at this juncture? Too easy? Too hard? Yeah. Now let's look at part 3. We want to find the equation of the normal at the curve where the at the point where curve intersects the y-axis. So that means that we need to observe the curve, find out what is this point, okay, where the intersection with the y-axis is at. Okay, I need to know what is the coordinates, because if I don't know the coordinates, I will never be able to find out what is the gradient value. Okay, more importantly, I need to find out the gradient of the normal. Okay, so first of all, I need to go and find out what is this intersection point supposed to be. So since it is intersecting the y-axis, that means your x is equals to 0. In other words, y equals to 0 cubed plus 6, 0 minus 15. Because we're looking at the curve and the y-axis, so we use the curve equation. So therefore, the intersection point is 0, negative 15. Okay. Then now I need to find out what is the gradient of the tangent first, which is dy over dx. Okay, so using x to be equals to 0, that means dy over dx is 6. Hence the gradient of the normal will be negative 1 over 6. Then we proceed to find out the equation of the straight line. Yep. Sorry? The gradient of what? Gradient of the equation. This thing itself. On top. Why? Oh, negative 5. It's negative 5, is it? Sorry, I'm right. Okay, so that means right at the start there. I was referring to this now. Oh, okay. My bad, thank you for pointing out. Negative 5. Okay. Not much of impact. Okay, then after that now we find the equation of the normal. Yeah? So using the same point 0, negative 5. Okay, our C will be equals to negative 5. So our equation will be y equals to negative 1 over 6x minus 5. Questions? Okay. Okay, why not now? Alright, if you have any questions, I want you to give this question a try. Exercise 13.1, question 5. Okay? My timer died, committed suicide yesterday after invigilating Vivian. Okay, so give you about 5 minutes. Okay, 10 o'clock we will continue going through this question. Okay. Given you more than enough time. Let's go through our answer. Okay. So I was looking at most of you were doing your differentiation. Okay, some of you choose to do product rule, some of you choose to do quotient rule. Either way is fine. Okay, so y equals to 3x plus 1. Since it is a fraction, if you choose to do quotient rule, okay, what you will get is that keep the bottom, make sure there are brackets, differentiate the top, minus away, keep the top, differentiate the bottom over 1 minus x bracket squared. Okay, and that simplifies to 3 minus 3x minus plus 3x plus 1 over 1 minus x bracket squared. Okay, so we have 4 over 1 minus x bracket squared. So that's our derivative. But then, that's not the aim of the question. Question wants us to find equation of the normal at the point where the curve intersects the x-axis. That means that we need to find out what is that point where the intersection is. So when y is equals to 0, we have this. I don't notice that there are some of you when it comes to dealing with this, when you cross multiply, you think that it will be 1 minus x equals to 3x plus 1. Okay, that's incorrect. Okay, so what we need to realize is that 0 means 0 over 1. Cross multiply is such that 0 multiplies with 1 minus x. So that gives us 0. 1 multiplied with 3x plus 1, that gives us 3x plus 1. So 3x equals to negative 1 and x is negative 1 third. Okay? So we see that the point will be negative 1 third and 0. Okay? Then now we find that the gradient of the tangent, upon substituting x to be equals to negative 1 third into here, you will have 4 over 1 minus negative 1 third. Okay, that would give you 9 over 4. Then now we find the gradient of the normal. Negative 1 divided by 9 over 4. That is negative 4 over 9. Therefore, equation of the normal will be y equals to negative 4 over 9x plus c. And at negative 1/3 0, we find that C would be equals to 4 and 27. 4 over 27. In negative 4 over 27. So therefore, this will be our solution, okay, to getting the equation of the normal. Okay. Right. Any questions? Okay. Next we look at try 2. Okay, let's look at try 2, right? Try 2, in fact, they make it seem so simple because they only give you one statement, okay, filled with a lot of information inside, and they want you to find the value of A and of B. Okay, so let's break down this one sentence that they give and understand what's it trying to say. Okay, so we are given this curve over here, and it says that the tangent to the curve, okay, at a point Q is perpendicular to another line. Right? So what you can draw to help yourself, okay, understand the question, is draw a curve first. Any curve will do. Okay. Then after that, there is a point Q, 0, 8. And the question says that the tangent is perpendicular to another line. Okay. So we draw a tangent over here. And then we want to draw another line such that the tangent is perpendicular to this. Now this is the part that we need to be careful about how we draw our diagram. Okay, there is a tendency that you might think that this line passes through Q, so you end up drawing the normal. Okay, but the question did not say that this line is found on the curve. Okay, it just means that it is perpendicular. That's all. Okay, so what would be better as a drawing is that you draw a perpendicular line away from the point Q itself, because the question did not say that. Okay, so if you actually end up drawing this line on where Q is, then likely it will lead to a lot of misunderstanding. Okay, then you end up using the wrong information. Okay, so that is this line 6y equals to 6 minus x perpendicular to the tangent. Okay, and the curve has this equation. Okay. Now that we have the diagram, we need to figure out a plan of how to find out the value of A and B. A and B are the unknowns found in the equation of the curve. Okay, so very likely, I need to make use of the information that we are given, whereby we have the equation of this line, as well as the point Q, and probably place it inside, okay, in some way or the other, into this curve itself. Okay. Now the very straightforward task that we can see at least now is that Q is found on the curve. So naturally this Q must satisfy the equation of this line. Right? Okay, or not say a line but a curve lah. Okay? So therefore, using that piece of information, what we can at least do is that I can substitute y to be 8 and then a to x, right? X will be equals to 0. Okay, so 8 is equals to b cubed, and we can find that b will be equals to 2. Okay, so that is the first observation we can make. And we have already found half of the question already. Okay, we need to next find out what is the value of A. Alright, so since I've already made use of this information, I'll make use of the next one. Okay, so the next one is slightly trickier. We see that 6y equals to 6 minus x. Okay, that is the equation of this perpendicular line. Perpendicular to what? Perpendicular to the tangent. Okay, we know that for perpendicular lines, their product of the gradients will be equals to -1. Okay, so what this means is that from the equation y equals to ax plus b cubed, if I were to differentiate it, I am going to be getting the gradient of the tangent. Okay, so what this expression means, it is the gradient of the tangent, right? And in particular, if it is at Q, the gradient of the tangent will be equals to 3a multiplied by a0 plus b. We already found b to be 2. So that will be 12a. Okay. So we are trying to make use of the fact that normal and tangent gradients multiply to give us -1. Okay. So the gradient of the tangent here is 12a. Okay. Next thing I need to find is the gradient of the normal, or not the normal actually, the perpendicular line. So we need to translate the 6y equals to 6 minus x into the y equals to mx plus c form, and find that the gradient is -1/6. Okay, so -1/6 times 12a must be equals to -1 because of the fact that the lines are perpendicular. And we find that a equals to half. Okay. The critical concept is this idea here. Whereby you probably remember it as m1 times m2 equals to 3. Next, last part to this question, it says find equation of tangent at Q. Okay, so I now already have the gradient of the tangent, which is 12a. Which is 6. And therefore, the equation of the tangent is y equals to 6x plus c. Since it is on the point 0.08, c equals to 8. will be y equals to 6x plus e. Okay, any questions? Okay, let's look at exercise 13.1 question 4. Right? I intentionally chose this question in order to break down, help you learn how to understand a question, okay, and interpret a question. Okay, so in this question itself, it says that the gradient at any point on a particular curve is given by this expression. So what does this sentence even mean? Okay. At this juncture, I hope that you have already developed, okay, the idea that gradient and dy over dx, they mean similar things. Okay, so dy over dx, we're looking for gradient. Gradient of what? Gradient of tangent, in fact. Okay, so it says that the gradient at any point, okay, for a particular curve, that means there's some curve, you don't know the equation, but the question tells you that the gradient has this expression. That means that dy over dx of the curve is 2 minus x over square root 1 plus 4x minus x squared. So this is the first thing that you must be able to interpret out of that first sentence. Okay? Then it says that given that the curve passes through a point, okay, we want to find the equation of the tangent to the curve at P. Okay, we still do not know what is the equation of that curve. Okay, so that curve can be just one random curve like that. Okay, we have a certain point P, 1, 2 over here. Tangent might look something like this. And the gradient of the tangent should satisfy this expression. Okay? So question wants me to find the equation of this tangent at P itself. That means since I have the point, I will substitute it into my dy over dx, where x equals to 1. And then I can find out what is the gradient of the tangent. Okay? So gradient of the tangent will be 2 minus 1 over square root 1 plus 4 minus 1 square. And that is equals to half. So I now have the gradient. I know the point as well. So we can now find the equation of the straight line. Y equals to half x plus c. Y is 2. X is 1. So c equals 4. Therefore, y equals to half x plus 4. Okay? 3 over 2 meter. Is it 1 day 3 over 2? Oh, okay. Oh, yeah, sorry, thank you. I multiplied 2 minus half, that will be 3 over 2. Okay? So with the questions that we're doing so far, whenever we find equation of tangent, equation of normal, we always need gradient and then also 1 point. Okay? So that we can form our y equals mx plus c. Then for finding the equation of the normal, you will find the gradient of the normal, okay, which is negative 1 divided by the gradient of the tangent. That's negative 2. So y equals to negative 2x plus c. Therefore, the equation of the normal is y equals to negative 2x plus 4. Yep. Questions? If no questions, then 13.1 is done. And with the end of the section, there is a homework. Okay? Question 6, 10, 11, 13. Okay? We already have 2 pieces of homework due on Monday. This one, Tuesday. Oh, 10. Any valid objections? 10 or not Tuesday? 10 Wednesday? Oh, people ask Wednesday. Wednesday better? Okay, can. Okay, I don't want to start a new chapter. Okay, I think I'll just end here for today. Right? Remaining time, you want to start on your own also can. Okay? So, because next one we're going to increasing and decreasing function. So I don't think I will have enough time to cover it meaningfully.